The human brain generates complex logic in milliseconds, but we force those thoughts through the slow, physical labor of typing. Traditional peripherals like keyboards and mice act as a rigid mechanical gate, limiting how fast human cognition can actually reach the machine. This raises a theoretical question. What happens if we remove the physical middleman entirely? To find out, a developer began the synaptic script experiment, hardwiring a persistent brain-computer interface directly to a Python environment for 7 continuous days. Researchers designed this as a rigorous stress test, monitoring whether human biology can sustain the load of a total mechanical replacement without a collapse in data integrity. The BCI hardware works by reading cognitive spikes, the raw biological metrics of human focus. Bridging software translates these focus patterns, organizing an erratic biological waveform into discrete data spikes. These spikes are mapped to executable Python syntax blocks. As the user maintains deep focus, the system compiles those blocks into functioning logic. This direct translation removes the physical possibility of typos and the delay of mechanical input lag. The logic executes in real time, firing the moment the user completes the thought. Bypassing the hands shifts the challenge of computing to an entirely new domain, the exactness of a user's neurological translation. Managing that translation becomes significantly more difficult over a continuous 168-hour timeline. Because the connection remains persistent, it creates a closed, recursive feedback loop. In this circuit, executed code generates a result, which the user immediately observes. That observation triggers new cognitive spikes and new code, accelerating the loop. The danger is the user cannot step away. Resting thoughts and mental fatigue are compiled directly into code. Within this recursion, a wandering mind is a structural threat to the digital environment. By the end of the week, the inability to break the recursive feedback resulted in severe psychological strain. This graph shows the impact of strain on the code. A sharp spike in errors at day 4 reflects rapid degradation in data integrity. As the developer reached exhaustion, the Python environment filled with fragmented junk code, a digital map of failing focus. In this state, the human mind functions like an open API, vulnerable to the very outputs it is creating. The final logs suggest that when the mechanical bottleneck is removed, system stability is tethered to the stamina of the mind.